Welcome to Brain Vision.
In this problem, we have a rod of negligible mass, which is subjected to a couple moment that is given. The engine of the car that is attached to the rod also has a traction force to the wheels. We want to calculate the speed of the car at a given time, assuming that the car starts on rest. So if we look at our free body diagram, we can see that the moment reaction, ms, has no component about the z-axis. The force reaction, Fs, acts through the z-axis, and the line of action, W and N, are both parallel to the z-axis. So they produce no angular impulse about the z-axis. So if we use the principle of angular impulse and angular momentum, we can see that the initial angular momentum about the z-axis, h1, plus the sum of the angular impulses over time from t1 to t2, the moments about z dt must equal to the final angular momentum of the system h2 about the z-axis. So since the car starts from rest, its initial angular momentum is 0. We then have two impulses, first due to the moment reaction, and we're concerned with a time of 5 seconds. So we integrate from 0 to 5. The moment force is 30t. So that's 30t times t is t squared. We multiply the moment by t to get our angular impulse, and we integrate that with respect to t. So we have dt. We also have the force reaction impulse, which again is over 5 seconds, and the force is given by the wheels to be 15t multiplied by the distance from the z-axis, which is 4 meters, dt. And this must be responsible for the final angular momentum of the system, which is the mass of car and rider, 150, times the distance of 4 meters, times the final velocity of the system, the final speed of the car, v. And that's what we wish to calculate. So if we perform these integrals, we are left, since these are definite integrals, we are left with one unknown. And that unknown is v, which we can then solve for. So the final speed of the car, v, is 3.33 meters per second.